Hi, welcome back to my stream. So yesterday I started developing an Alexa skill, and I want to definitely continue that today, and that's what we're going to be doing. Let's take a step back first, though. So thanks for joining. My name is Ryan. I am a technical evangelist for Amazon Alexa. My job is to inspire and educate developers to create Alexa skills. That's what we're going to be doing here on this channel. So the use case that I'm kind of working towards is one where we're going to be building a skill that will index videos on YouTube. So the use case here is once a week, I and my co-host Jeff Blankenberg get online and answer office hours for Alexa developers. We do this every week, and when we're done streaming, we host those videos in YouTube, among other places. And one of the things that we realize is that we have this whole repository of videos that have answers to questions in them, but it's really hard to get those answers out. And so what I'm wanting to do is create a skill that will allow us to go and retrieve answers from those past videos. And that's what we're going to be doing. So the idea here is we're going to be using a bunch of AWS services that will allow us to go grab YouTube videos, pull them down, transcribe them, and index them. And then we're going to create an Alexa front-end skill so that we can say, show me office hours videos where we talked about Alexa presentation language, or APL. And the idea being from your device, whether it has a screen or not, it would go to that point in the video and either play the audio or play the full video and show you the answer. And then you could say next, and so on. So we're going to go through that, the development of this skill. I have this somewhat in my head. I don't have this fully designed out. I do not know exactly what I'm doing. But we're just kind of go along for the ride. So I started this yesterday. It was more me fumbling around trying to get oriented. I decided I just wanted to start streaming and start going before I had this all figured out. So yesterday I did a bunch of stuff to kind of orient myself. Now today I think I have a little bit better grasp on it, and I think a good place to start is going to be in designing like an architecture diagram. And this is going to be a live document. I'm not going to design the entire thing today because I don't know what the entire architecture diagram is going to be looking like. But I think we can get started on it and kind of explain along the way. So join me as I fumble through this awkwardly, make mistakes, write terrible code that then has bugs that I need to go and troubleshoot and so on. I should also say that at the end of every stream, I plan on checking in this code. So it'll be completely in my GitHub repo, fully open source. This is what I checked in from yesterday, which is really just initialization of a project using SAM, the serverless application model framework from AWS. But the idea being at the end of this, anyone could just go check out this repository and use it to go and create this infrastructure in their own environment, or just pull apart the source code, have fun with it, and build something way cooler. Okay, so let's start by design. So yesterday I just jumped in and started writing a couple Lambda functions. It felt awkward, but I just wanted to get going and get moving. And that's actually how I approach most of my development is I get paralyzed by trying to plan it. So what I do is I just jump in and start building. And then things start to come to me and it kind of makes more sense. So now that I have a little bit better idea, let's start in, this is just Lucid charts. It's what I use to create my architecture diagrams. So let's just start going. So at one end, we're going to have YouTube. So let me go find an icon for YouTube that I can use. Just bring that over. And then at the other end, we're going to have Alexa, right? So the idea being that anyone with an Alexa device that is pictures of females named Alexa. That's not what I was looking for. Great. Let's see if we can find an echo show. Cool. So here, this is kind of my end result of what I'm looking for. And the idea being, so I do have a couple Alexa devices over here. I would like to be able to, at some point, be able to use these devices to interact with this whole thing. So I don't know if that's going to be months from now, but that's kind of the end goal. All right. So let me make this a little bit bigger. So these are our two kind of main players here. And then there's just a bunch of other stuff. So there's going to be an AWS cloud, which is going to be actually a huge chunk of this. And then there's also, let's see, there's a generic one here, I believe. This is corporate data center, but I'm just going to rename this to Alexa console. And that will make sense later. And we're probably not going to get to this part for quite a while. My goal is to build the whole backend infrastructure so that we have a database where we can search before trying to go after the skill, which will then search that database. Okay, so we need some way to get videos into AWS. So we can start indexing them. And I haven't figured this out, if this is going to be a webhook API from YouTube saying a new video is available, go download it, if it's going to be like a Zapier integration or some sort of third party, if this then that integration to kind of bring it over. But what I do know at this point is that I want to get this into Amazon S3. So Amazon S3 is Amazon Simple Storage Service, is where we're going to store large files. Let me actually draw that. So here, here's my arrow. So basically, and I'll fill in these details a little bit more as we go. I haven't quite figured this out. But I do know that I need to get the YouTube video into Amazon S3. And one of the things that I've also learned is that the services, well, actually, let me get to that. So now I have the video in S3. I could serve this directly up to Alexa, which is actually kind of cool. So let me draw that. And boom. So now I have a video in S3. I could create a skill that just plays that video. Great. Doesn't really help us because we have a repository of hundreds of videos now from office hours every week. So how do we know, like the idea being, I could write a skill right now that said, just go and play last week's office hours. That would be kind of cool. But I want to do more than that. I want to say I'm having trouble with APL, find a video about that and have it zoom to that part in office hours where we're talking about it. So I need an index, I need a database, I need a search. So in order to do that, I need to first pull out the words from the video. So as we're speaking, Jeff and I, we need to be able to pull out the words. There is a really awesome AWS service called Amazon Transcribe, which will do that. So here, actually, let me draw the arrow the other way. So file lands in S3. We then pick it up with Amazon Transcribe, and Amazon Transcribe will then go and take and pull out all the words and paragraphs from that video so that we have text around it. There is another service called Amazon Comprehend, which allows us to, actually, let me pull up the page for Amazon Comprehend. So Amazon Comprehend is another natural language processing service. Amazon Transcribe is the first one we discussed, which is speech to text. So automatically convert speech over to text. Really, really cool service. And then Amazon Transcribe derives and understands valuable insights from the text within the documents. And we'll show why this is necessary as we go, but we don't just want to dump just a bunch of raw text into a database. We want to try to understand more, extract value out of that text before we go and do that. And that's what Comprehend allows us to do. And again, we'll get to more details on this as we go. And then, so we've transcribed it, we pulled out the value. Now what do we want to do? We want to put this into a database where we can do searching. There's a bunch of different databases inside of AWS, all, we like to say, purpose-built databases. They all have different purposes. We're going to be doing full text searching. So we're going to have these paragraphs of text, sentences of text, and we want to be able to search that. So the best tool we have for that inside of Amazon is Amazon OpenSearch, which probably they don't have the graphic for that yet. It was originally called Amazon Elasticsearch. That's probably what it's called here. This is a third-party tool I'm using to create these diagrams. Let's see. There's got to be. There it is. Okay, that's Elasticache. Sorry. All right. They don't have that, so let's just try Elasticsearch. They do have it. I just missed it. Okay, so we'll put this into Amazon Elasticsearch, and now we have a database. So first step in what we're going to be building is kind of this pipeline here of videos coming off of YouTube. So we host office hours. The video gets archived in YouTube. It gets pulled in automatically, and we haven't figured out the mechanism yet, but then it'll go through this whole chain process, and new content will be available inside of Elasticsearch. Now, one of the things, so I did play with this a little bit a few months ago. One of the things I did find out is that when you download a video from YouTube, it's in a different format than what Amazon Transcribe can use. And so there's actually another service inside of AWS called Media Convert. And so what I'm going to do is I'm actually going to drag this down and move this up. So one of the first steps is we need to apply Media Convert to this. Let me just do that. So what Media Convert does is it just converts two different types of media. So we're going to take the video in YouTube format and resave it in a new format that then Amazon Transcribe and these other services can leverage. And for purposes, it will probably show clear here in a minute. I'm just going to draw this down here. Okay, so now, so this, we still want this. So this is the play video. But, and this is how it actually works. When you play a video, again, we'll get this in the future, but when you tell Alexa to play a video in Alexa skill, you actually give it the source, and let's actually modify this. So you can actually say, here's the Amazon S3 bucket where this video is located, and stream that way. I prefer to use Amazon CloudFront, which is a content delivery network, so or CDN, to put in front of it. So the idea here is that this becomes kind of like a caching mechanism. You can also apply a little bit more security to it. It's just kind of a best practice, and I like to do it this way. Okay, so that's how we play the video, but how are we actually going to do the search? So what I'm not showing here is a bunch of Lambda functions, but one of the main Lambda functions is a Lambda function for the Alexa skill to do kind of all the skill logic. So we're going to put that, it's kind of like the back end. We're going to put that inside of Amazon AWS. When we create a skill, and we'll show this, and again, in the future, it's probably going to take a while before we get to that point. But when you create a skill, you can say, I want to have Alexa host my backend code, in which case Alexa console will give you a Lambda function and everything else. And that would look like something like this, where it's an Alexa hosted skill. We're going to do more custom work, so I want to actually host the Lambda skill myself and then have Alexa talk to that. So then from my skill, we will do the querying. Let's connect the dots. So here we'll query and pull back the results, which will then allow us to go find the correct file and serve that back up to the device. All right. There's some Alexa console stuff here. I'm going to skip it for right now because the main stuff we're going to be focused on for a while is inside this box. This whole chunk here, I think it's going to be, we will utilize Amazon step functions to orchestrate a lot of this. So I'm just going to draw a box around this to represent that this is Amazon step functions. And Amazon step functions is going to use a lot of Lambda to orchestrate a lot of this. So when I draw these diagrams, I like to draw diagrams that kind of show or tell a story, not necessarily very specific, like every single architectural detail and how it all connects. So what's missing here is a ton of Lambda functions that are going to handle a lot of this processing. And maybe I could draw each step function out individually later, and I probably will to kind of help diagram that out. But this is just kind of like a 10,000 foot view of what's going on. Okay, so let's talk about this. So I think we need some users. So here we have users talking to their Alexa devices, asking about different videos. And then we have, I'm just going to put a text box. Where's my text box? We'll just say office hours goes into YouTube. Okay. Make this a little bigger. All right, so how are we doing? Okay, every Tuesday, Jeff Blankenberg and I get on office hours. Sometimes we have guests. We live stream talking to Alexa developers, answering questions. That gets archived into YouTube. Then we have some sort of trigger, yet to be determined. I see to look at APIs. I need to understand like what the YouTube events APIs looks like, et cetera, et cetera. Some sort of trigger to kind of pull this down into Amazon S3. Inevitably, there's going to be more Lambda here. There's probably going to be an API gateway to receive a webhook, and so on and so on. Let's not worry about that too much right now. I have a YouTube video that I've downloaded that we can use to kind of kick off this whole process, and then come back and figure out how to do the input part. To me, that's less interesting than actually this whole process here of transcribe, comprehend, and full text searching, and the media convert. You know what? I'm going to actually draw this more like back and forth. There. Anyway, I'm being nitpicky. Okay, so lands in S3. Now what we're going to do, we need to first do a media convert on this. And you know what? This is probably just going to be part of the whole step function. So let's just do this. So the step function will kick off. It'll orchestrate. So step function I use for orchestration. Orchestrate converting the media, writing a file back in a format that we can then process with other AWS services, and then kick off transcribe, and then comprehend all in just a single video, and then store the results in Amazon Elasticsearch. And then, so this part here we'll get to much later, which is the Alexa skill part. But if we can just do this part over the next few weeks or however long, that it would be very exciting. So let's work on this. Okay, so yesterday I, again, was just kind of trying to figure out how I wanted this to all work. I ended up building out a couple different Lambda functions. Let me pull up in my code here. I ended up writing two different Lambda functions. First one to start the transcription process, and the second one to check on the transcription process status. And I wrote it all up using the SAM framework, again, the serverless application model framework that AWS has, and deployed this out. And the more the focus was on establishing the repository, establishing the SAM project, making sure that I had the right AWS account connected, and I was able to deploy all this. I didn't test any of it, make sure the code was actually executing. I'm not entirely sure if I have the correct permissions yet set up on these. It was just more to kind of just get established. The other piece of this that we did a lot of talking about yesterday was I kind of got this idea after following this blog post from a while ago, where they are doing the kind of the exact same process, but with a audio podcast RSS feed. And so this is kind of what got me inspired, got me thinking about it. And I'm going to borrow a lot of the source code that they've open sourced in GitHub as kind of a starting point. I enjoy the way that they have put this together, and a lot of it I can just reuse. A lot of it I had to rewrite. And there's a lot of differences in the use cases, but overall, I think a lot of it is a good place to start. And that's what this code is here, is mostly me just borrowing from them. I am going to go through and update a lot of this code as we go to clean it up, make it a little bit better, or not better, more suited towards my use cases, I should say. But we'll just take it as we go. Okay. So yesterday I created those. So I started here, this Amazon Transcribe, and I created 2 Lambda functions. And I also talked about the way that they are using step functions. I really enjoy and really want to leverage as well. And so the idea here is that Amazon step functions is kind of like an orchestration tool. At least that's how I use it. I think it could be used in a lot of different ways. And here specifically, we're going to use it to orchestrate different Lambda functions. So we could, in theory, write one big Lambda function to handle all this. We could also just spin up an EC2 instance and deploy all of our code onto a server and say whenever an S3 file goes, we then process it using an EC2 instance. I much prefer serverless technology. I don't want to be managing an EC2 instance. I don't want to be managing software updates and OS vulnerabilities and all that. So we're going to use Lambda. And there's a couple of key things about Lambda. The first key thing is that you are charged in Lambda by how long your code is actually executing. So I really, really like this pattern that they're doing here. I use it all the time in a lot of my other repositories, where what we're going to do is we're going to break up these tasks into small little bite-sized lambdas. And when I say that, what I mean is like the lambdas are going to be like 100 lines of code or less, and they're really only going to do one thing. So here, my first lambda, all it's doing is starting the transcribe process. It's building up a bunch of metadata and going, but it's 114 lines of code, and really it's just calling start the transcription job. This kicks off, and then what it does, so the way it's designed is that starting a transcription job may take minutes. It may take 20 minutes to execute as it's going through the entire YouTube video, finding all the text and so on. So what we want to do is we want to start the transcription process and then stop. So the Lambda function should execute in a few milliseconds. Versus waiting on 20 minutes. And that keeps our cost down really low. So how do we know when the transcription process is done so we can move on to the Amazon comprehend process? Well, we write another Lambda function that all it does is check on the status of the transcription process. There's an API, what's the status? That's what the second Lambda function is that I wrote. Get transcription job, which part of the API response is the status. So we're just going to pull on that, and we're going to use step functions to kind of orchestrate that loop. So we'll have step functions kick off the first Lambda function. It'll get the result from that Lambda function, which is the job name, and then we'll just wait, call the status job, wait 2 minutes, check the status again, wait 2 minutes, and so on. And so then our overall Lambda execution time is still in the milliseconds, but we can wait for these really long tasks to happen. And then once that's done, then we can go on to the next step, which would be to have Amazon comprehend, take a look at it. Okay, so we can do all this in the SAM template inside of this is a SAM template. It's built on, I'm probably going to not say this correctly. It's built on top of CloudFormation, but it has a transform. So we can define things a little bit simpler because we're using the service application model SAM framework. This will transcribe into 2 different resources in standard CloudFormation. After it will go and build the code, pull down the requirements, package it up into a zip, deploy it to S3 and a bunch of other steps. But in this, we can also define standard resources. So one of the resources that we need to define, we've started that. We've started the 2 lambdas. Now we need to orchestrate it. And the way that we do that is by using the next CloudFormation. Where did it go? So let's go and look up the Amazon CloudFormation step function syntax. Okay, which is, it's actually a state machine is the resource type that we're going to be building. So one of the key things here, I could go into Amazon AWS account and just go and create a new state machine. Actually, let me delete these. I don't need these anymore. These are old state machines that I don't need. What I could do, what I was saying, is I could come in here and create a state machine and use the UI to define exactly what I want to build. This is kind of less than ideal for a few different reasons. The first one is, this could be good for coming in and kind of exploring, designing out what I want to do. But if I wanted to redeploy this in a new environment, it becomes very difficult to do that. Or if I wanted to put this in GitHub so other people deploy it, which is what my ultimate goal is, that's also kind of difficult to do. So my preference is to use CloudFormation to design out those resources so that we can use infrastructure as a code to deploy these out there. And then the way this works is you can build a step function in CloudFormation, define it there, and every time you make a change to it, you just redeploy your infrastructure through, in this case, SAM, which will redeploy it through CloudFormation, which will then update all my resources. And then anyone else can just kind of download it and play along. Okay, so let's do the, let's call this pipeline step function. So we're just giving it a resource name. And I really need to fix my indentions in. Okay, and so this is the definition here. Oops. Okay, so it's a type state machine and has properties. A lot of these properties, what I like is that the documentation for CloudFormation will have everything you need to know here inside the documentation. CloudFormation CloudFormation, when you first look at it, I think is not the easiest to kind of follow along with. But once you kind of get once you start getting familiar with it, I fell in love with it at least. But it might take a little bit of getting used to. So you can see here which properties are required, which properties are not required, and so on. I'm going to cheat and let me do this off camera for a second. I'm going to find an example in my past that I have used step functions on, and I'm just going to start pulling from there. I hardly ever, my dogs are barking in the background. I hardly ever start from complete nothingness when doing this. So I like to have a bunch of other code repositories. So here is one that I've used in the past. So this, in a previous life before I was an Alexa evangelist, I was a AWS solutions architect. I was a specialist for a particular service called Amazon Pinpoint. And one of the things I did was maintain this repository here, along with Dave Lemons and a few other of my colleagues. And in this, I've created a bunch of examples in CloudFormation, but I go back and reuse a lot of this stuff over and over and over again. And so I hardly ever just start anything from scratch. I definitely copy and paste and kind of steal from myself, which I recommend anyone to do who's a developer. Okay, so here, this is a state machine I've previously defined. First thing we need to look at is we do need a, I'm going to call this a state machine. So step functions is the name of the AWS service. State machine is the actual resource that we're looking at. Okay, so we do need a role for this state machine. So I'm going to, down below, create a role definition. And let's see here where, it should be down here. Oh no, where is it? There it is. Okay. So we have another resource of type IAM role and properties. Okay, so the properties of this is that it needs to be able to assume the role from state machines. So here we're just saying this role, we're giving step functions the ability to assume this role to be able to execute on. IAM can get really, really complex and crazy as well. I certainly am not going to be able to explain everything that this is going to be able to do, or everything that IAM can do, but just hopefully follow along. And I know how to use IAM fairly well. Okay, so this is the definition of a role. Because it's going to be used by state machines, we have the assume role, and then here are the policies. It can invoke two functions. Obviously, I just copied this over, so this is not going to be the proper ARNs, but let's start here with this. These are my two functions here. So we want to be able to say when step function starts executing this step function, it's going to assume this role, and then it's going to have permission to invoke these two functions. That's all this is saying at this point. So now if I come back to my state machine, I need to say state machine instead of step functions. So now here I can say, is this correct? I'll explain this in just a second. I'm just going to make sure this is the correct syntax. Come up here. Yeah, get at. Okay. So here what I'm doing is I'm saying the role for this state machine is this resource's attribute, get attribute of ARN. So this will basically pull in the ARN attribute off of this resource and plug that in when this kind of gets deployed. Okay, so what else do we need? Now we need a definition string. So when you are creating a state machine, you give it a definition. And here, let me just kind of pull this all over. Again, I'm stealing from myself. Okay, so this is the definition string in JSON of the entire state machine. Okay, so you basically define where it's starting at. You define a bunch of different states, which are kind of like the different blocks. So if I, actually, I bet in this repository I have, tell me I have, yes, okay. So this is a screenshot directly from the AWS console from state machines. So here, this is what a state machine looks like. Actually, the one I'm copying from looks like, where these are different states throughout the process. And again, you can see this follows the exact same pattern I described above. You create a campaign. This is doing stuff in Amazon Pinpoint. Again, I'm just borrowing from it. I'm going to replace all the details. But here's the same pattern. You kick off a long process. You wait. You check it to see if that status is finished. If not, you keep waiting. Otherwise, you move on. So it allows you to create Lambda functions that do very simple tasks that cost very, very little, and use state machine to execute this whole entire thing. Okay, so we don't want to do create campaign. We're not doing anything with campaigns. We're not doing anything with Pinpoint. We're going to replace all this. So the very first step we're going to do is transcribe start is the first state that we're going to do. So I'm going to say this state machine starts at transcribe start. I've just defined that here. This is a task, and the resource would be the ARN of the Lambda function, which would, this gets a little bit tricky. So I'm doing a substitution on this entire thing. And so my substitution string is transcribe start ARN. And down here at the very bottom is an array of, or a map of all the different substitutions. So let me just get rid of the rest of these. So here I'm replacing transcribe start ARN with the attribute from my transcribe function of ARN. It's kind of a mouthful. And so that will get replaced up here. Next will be, this, we don't want that. We want transcribe wait. Okay, so here we're going to wait. Here it's waiting 10 seconds. And then next would be transcribe status. Okay, and here transcribe status, resource, we're just going to do the same exact thing. The resource, we're going to replace that string with down below. By the way, there might be other ways of doing a lot of what I do in CloudFormation. There might be way better ways easier ways of doing it. This is just how I know to do it, so I'm fastest doing it this way, and it works. So that's how I do it. So now we want to do is transcribe finished is kind of the next step. Okay, so we start at transcribe start. It runs the first function, and then goes into this wait state. The wait state runs, or waits 10 seconds, transcribe status. This goes, when this done, it now goes into transcribe finished. Okay, so the default on transcribe finish is go back to transcribe wait. But here are the different choices. So when transcribe status runs, it has a return result. So let's go back to that function. And I just do this over here. Okay, this is my transcribe status function. So here it pulls back the status and returns status. So in the variable dot status, it will, oh, come on, don't do that. It will have the status of the step function. Okay, which is a return response of this API. So we need to know what these various steps are. I stole that code, but if we were to open up the Bado3 transcribe API. So Bado3 is the Python SDK that I'm using. It's let's see. So we're calling get transcription job. So here, get transcription job. Let's look at the response codes that are possible here. Transcription job status. I skipped over it. Okay. Status of the transcription job. You're not going to give me a definition, are you? It does not tell me what the different values are. Oh, that's silly. Oh, here it is. Okay, so queued, in progress, failed, or completed. We want to know if it was successful or not. So really the two states that we care about are completed, which means we can go and move on, or failed, in which case we need to handle the error of that. The step function that I copied this from, one of the things that it does, which I like, is that it will, let me pull up the documentation. It has a couple different steps where it will post on Simple Notification Service what's happening with that. I'm not too concerned about doing that yet. I might come back and like add that stuff in later, but let's just remove those for right now. Again, this is another fail step, and let's just add our own definition here. So we have, we don't want trans, we want trans failed and transcribe success. Okay, so what happens is this will call to get the status of it. If the status is failed, it will go to a state called transcribe failed, which I haven't defined yet. If it completed, then it'll go to transcribe success, which I haven't defined yet. Otherwise, any other choice, the default will be transcribe wait. It'll go back into a wait process. And it'll do that if it's still in queue or if it's in progress. Okay, so now let's do our transcribe success. I already have a closing bracket here. Let's actually pull open the state machine documentation to figure out what is the best. I should do AWS. To figure out what type of test. So actually, this would be a good fail state. So this was transcribe failed. Cause. If it fails, we definitely want to take note of that and inform ourselves to go look at the logs for more details. If succeed, let's just do type equals succeed, and I think we do end equals true. I need to look that up. Okay. Use my step function, that'll be useful. And true. Okay. Okay, so this should be a good enough step function. I think 10 seconds, let's make it 30 seconds. I think the transcription, these are gonna be hour-long videos from office hours, so I think it's gonna take quite a while. Step functions, state machines do have like a max execution of number of states. They can last a really long time. Like you can have state machines that execute over like weeks. But there's a certain number of steps that a state machine is allowed to go through. And so those state transitions, we want to be careful on. If we waited like 1 second, then there would be a ton of state transitions as it is looping through and checking on the status of the transcription job. And we don't want that many. We want to keep it pretty short. So this defines a state machine. So again, this is the JSON that describes the state machine. So I'm designing it in JSON, which is then stringed up into a YAML file. And I'm applying a substitution to it so I can inject my two function ARNs into that so that it knows exactly what resource to call. I've given it a role, which is allowed to, so that the state machine can assume this role and invoke these two Lambda functions. This is a good first pass. I'm totally expecting this to fail as I deploy. So I fail a ton, and then I just fix the bug as I go, which is kind of fun. Okay, so let's try. So I'm going to use my SAM CLI to package up this whole entire project, and I'm saying use container so that it will. Is it SAM build? Yeah. Okay, so then it's going to use a Docker image to kind of bring this all together. So to prepare all the Lambda functions to be deployed in real Lambda. So I'm assuming the build is going to be successful. I'm assuming the deploy will not be. So that did succeed. Now let's try and deploy this. So what this is going to do, let's see if I got rid of all my, okay, got rid of all my state machines. If I go back to CloudFormation, I've deployed this once with the two functions. That's what I did yesterday. So here it is, unofficial office hours. So this is what I'm going to be updating. So Sam is going to, look at that. So far, so good. I don't have any major syntax errors. Sam didn't find any issues. So here you can see what it's going to do is it's going to modify the current stack that's already out there in CloudFormation. It's going to add the role and the state machine, and then it's going to modify transcription start. So I must have modified this function, and so it's going to do a in-placement update, or it actually has to replace it. Okay, so let's see if this works. Okay, it updated the function. It's creating the role. Hopefully the role isn't too big of an issue. The role was created. That's a good sign. Now it's, oh, and that looks about right. Okay. Invalid state machine, invalid JSON description, unexpected character, was expecting comma. Okay, so the problem is it doesn't always give you the greatest error messages. So usually I have something like that as a problem. Okay, just double checking all my other commas and double quotes. It looks pretty good. That's the close of that. This is the close of that. All right. It's rolling back. So again, this is another great thing about CloudFormation is it's going to roll back the state to a working known state. I believe that that's something you can configure to not roll back automatically. Here, we definitely want to do it that way. I'm hoping that was the actual error. Satisfy constraint. Member must have invalid definition. It's got to be. That was definitely one issue. Interesting. We're just going to wait for this to roll back. Let me check the status here. You can see it's rolling back. We should get the same exact error message here. It's talking about a status message, but I think it's just the other. I missed comma. So when it's rolling back, what it's going to be doing is it's going to roll back the creation of the two roles, or just the one role. It's going to roll back the creation of the state machine. So if I come back here, there should be no state machine. And then it also has to replace the Lambda function that got updated. Okay, so it deleted the state machine and rollback complete. Okay. So I fixed that one. I don't believe I need to rebuild. I think build is only for the Lambda functions. Let's see what this does. Hey, girl. My dog. She's a good girl. Okay. Let's try this again now that I fixed my bad JSON. It's creating. Dog next door is barking, so my dog is a little bit upset by this. Oh, we got another error message. Okay. Invalid JSON description. Unexpected character. So we still have another problem. I will try rebuilding just to make sure that that's not the issue. But let's see if there's any I don't know if Mike's picking that up, but my dog is very sad. She's crying. Just looking for misplaced double quotes. Unexpected double quote character. Was expecting comma to separate object entities. You know what? I probably have to do another build. And then this is just quoting the entire description. Well, does this have, let's see here. Where did I fix that? I fixed that under Transcribe success. Oh, it truncated it. Dang. Well, the other thing we can do, so I talked about this. We can just go in and try to create this manually, just to verify if our JSON's even remotely close. So it's right. Let's try this. Look at that. Okay, that's not a valid ARN. I expect that error. End is not supported. See, there we go. That is great information to have. Okay, so we want to, I think maybe just a pass is what we want. Bear with me. Okay, so a pass will work. You cannot, let's just do this. We'll call this end. We'll call this end. And then we'll say, cool. Okay, I think this is what we want. See how useful this can be to actually go into the console. But I don't want to create it there. I still want to create it in code so that we can deploy this. Okay, so now pass, true, error. Oh, and so we'll call this end. We'll call this end. Okay, transcribe failed, goes to failed, end. Okay, this looks okay. I'm going to say end because the next step is actually going to be a comprehend service call in Lambda. But for right now, let's just put the end there, and we can just keep pushing the end down further. And type pass is just kind of a trick I have where you need some state, but you don't necessarily want to do anything. And so I use a pass for that. And it has to do with passing inputs and outputs. So I should say also that step functions, you can do really complex things with passing data around. So when you call a Lambda function, you pass data into that Lambda function. The return of that, you can pass back information. And then inside the state machine JSON, you can define all these different JSON paths to be able to manipulate those variables. We're going to have to do that a little bit. I'm hoping to do that very, very subtly. So the first example here you see is doing like $.status. So it's taking the result of transcription status and looking at the status return value. So here, that's exactly what I've done here. We'll work on this a little bit more in the as we go, but you'll kind of pick up on it's actually quite complex. Okay, so we've updated that. Just for let's actually just build it. It takes only a few seconds to build it. And then deploy it again. My watch just told me it's time to stand up. It probably is, but that's all right. Okay. So that got built. Now let's do SAM deploy. Do I want to deploy this change set? Yes, I do. And let's hope this works. Another thing that I like to do, especially CloudFormation, is do little deployment updates. So here I've just created one state machine with 2 lambdas. I could go and create all the lambda files, create a really complex state machine, and then deploy at the end. But the way I code, I would discover a ton of bugs that I have to go and resolve. So I like doing like these little incremental things so that I know exactly where the bug is. It's in the last bit of work that I worked on. Now, if I was a real software engineer, I'd probably sit down and design all this out, document everything, make every single thing like absolutely perfect before I started. But I'm not a real software engineer. So let's go here. All right. It has been created. So now if I go back, note, I did not create this way. I'm going to cancel this creation. But here I have a pipeline state machine. So the name of this got created from you could specify a specific name. I don't like to do that because then if you try to deploy infrastructure more than once, then you have naming conflicts. So what I prefer to do is leave off the name. So here you can see one of the properties you could include as a name. I left it off. Instead, CloudFormation uses the name of the resource and then some random variables to make sure that like I could deploy this, this infrastructure, this CloudFormation template 20 times this account, and it would not conflict at all. Okay, so let me go into this. Let's look at the definition. It's exactly what we wanted. Okay, so I could run this right now. And in fact, let's actually do that. This does take input. Actually, let's not run it yet because I do not have an S3 bucket yet. Okay. So what we've done so far is this whole process. So we've started the stub of the state machine step function, and we've called Amazon Transcribe, and then we've checked on the status of it. So if I were to run this, which I can't because I don't have a video yet to actually transcribe, but if I did and give it the right inputs, what you do is I'd say start execution, and here I would define my inputs. And the inputs I would put into the state machine, and the state machine would pass that on to the Lambda functions. So as an example, my transcribe start Lambda function assumes a few different things. It needs a media location, bucket, and key. And then it also needs, I pulled out the vocabulary information. We'll talk about vocabularies in the future. I think it will be useful, but we're just going to ignore custom vocabularies right now. But it needs content type. So if I were to, so what I'm saying here is that I could pass into this state machine bucket name, and then key, and then the other thing that it needed was content type, one of these dictionary items. Yeah, the interesting thing here is that, oops, what'd I do? I clicked on something. Where is it using the content? It's using media type. Okay, so convert content type to media type. Okay. Okay, so what it's looking for is this input string here. This is, again, most of this code is what I pulled from that blog that was open sourced. And so I'm probably going to come in here and rewrite some of this and clean it up and change a lot of this. But for right now, this is what the Lambda is looking for as an input. Obviously, the bucket name would be replaced by bucket name. But what I can do is I can put this into the state machine and actually execute it this way. And let's just see what happens. This is going to fail miserably. But let's see where it fails, because this might be interesting. So I started it off, the state machine. It's going to call transcribe start, and transcribe start failed. Are we shocked? No. So here we can go look at we can click on this state, which will pull up the Lambda definition, and we can actually go look at this, or we can look at, this will take us to the Lambda function, or this will take us to the CloudWatch logs. And here is that. And unable to import module app. So let's take a look at that. Interesting. Oh, no module named common lib. Look at that. So one of the requirements, let's go back and look at this. Okay, so I stole from this project here. Interesting. One of these, okay, so yesterday I was trying to be clever and pull out requirements that weren't necessarily needed. Okay, so yesterday when I was creating these functions, I definitely know that these two are not needed. I tried to reduce the requirements that be brought in through pip as down as low as I could. And so I just pulled out a bunch of them. But that is obviously causing an issue. So now if I were to let me kick this off and then talk. So what happens is I define my requirements here, my dependencies. When I do sam build is going to go pull down those requirements, dependencies, package them up with my source code into a zip file, so that, and then I can load that into Amazon. So it was, okay, it was the ID generator. Neat. Okay, so now if I deploy this, I don't know if this makes for boring watching, but this is how I program. I fail a ton, and then I fix the problem, and then I find the next failure. So here, It's modifying a bunch of stuff. That's interesting. I wonder what it caught. Okay, it's updating. Updated the functions already. Cool. All right. Now if I go back to my step function, so the other cool thing here is I can look at and say, okay, verify that this lambda function was passed exactly what we wanted it to. So this was the input to the step function, and it passed it directly into that. What I can do now is say new execution with the exact same input, and oh, it failed so quickly. Here is the new execution. Wait, was that the right one? Yes. Still no module name common lib. This is the downside of just copying and pasting code. You son of a gun. Okay, I see. They have their own. Okay, let's get rid of common. Now I get it. It wasn't even a requirement. It was just something they brought in. Okay, so ID generator. Let's just actually define that. Here. Is string imported? It is not. So we don't need logging twice. Random and string. Now we've satisfied that requirement. The question is, does this doesn't use that at all. Okay. So now, because what I did is I just brought in a bunch of, so each of these Lambda functions now have a ton of requirements or dependencies that aren't needed, but we're just going to leave them in there for right now. I can go back and clean that up at some other time. I think we can take them back down to like almost nothing. The original blog post that I pulled from, what they did was they used one set of requirements, dependencies for all the functions, and so they kind of just packaged everything up together. I prefer not to do it that way, so that's why I'm taking a different approach, trying to keep it a little bit more clean. Right. All right. Okay. So let's come back over to my step function, which has now been updated, and say new execution. See what happens. And actually, I can just go and I already have the CloudWatch logs open. So here, an error occurred. The S3 URI that you provided points to an incorrect region. Make sure that the bucket is in. Boom. Okay, so that's the error I was expecting. It still failed. Obviously, it's going to fail. I gave it an invalid bucket, but that's totally fine. I don't have yet, at this point in time, a valid file to work with. So how do I fix that? Well, I need to create now an S3 bucket. And the way that I would like to create this S3 bucket, we are going to do it in CloudFormation as well, is the key there. So now I need to find, again, I just steal from myself. So there's let's see, in this repository. This repository is one of my favorites. Pinpoint event processing, again, totally fine. Okay, so the reason why I definitely like to copy bucket creation is because there's a very specific and very secure way that I like to create buckets, which is kind of verbose, but again, I copy and paste for myself all over the place. For some reason, I always put buckets at the top of of whatever. That's totally fine. You know what? This isn't. I think that's not the right one I want to copy from. Let's do this. Ooh. Actually, so one of the so again, in my previous life, I was a solutions architect in Amazon AWS for SageMaker. Or not SageMaker, sorry. I was reading SageMaker for Amazon Pinpoint, which is way less intense than Amazon SageMaker. And I wrote a solution, predictive segmentation. And when you do when you create a full solution in AWS, it has to pass by a ton of different security concerns and audits. And so I like to steal. That was AWS Labs. My bad. I like to steal from myself a lot, and especially in these templates, because I know that they've been vetted, they're good, they've gone through all kinds of other reviews. Yeah, this looks better. So this is all I really need. I don't need all of that. Okay, so here I'm going to create a data S3 bucket. I'm going to put data retention policy of retain. So what, I'm going to remove the CloudFormation nags. So data policy retain, that means if I delete this whole deployment, if I delete this CloudFormation, it'll delete all the other resources. So my Lambdas will get deleted, my roles will get deleted, my state machine gets deleted, it cleans up, but I want to retain my buckets because that's where data lives. So I say retain. And then here, public access block configuration. So S3 is a great place to store large amounts of data and raw data files. And AWS does its best to make sure that you don't open it up in a way that will cause a security issue. And so we have all those controls. This is kind of what I've learned to be the best practice, is kind of all these settings. So we're going to turn on server-side encryption. We're going to block public access. And we're going to create a log bucket. So here, official. So what this means is that this bucket here, wait, where is the log bucket? I didn't get the log bucket. Here it is. I'm actually going to turn this off for right now. So what this would normally do is that every single time you access data inside the data bucket, it would log that interaction in the log bucket. So you have history of everything that happens. For audit purposes, you can go and find out exactly what happened. I think for a public solution, that's really good practice. For what I'm doing, I don't think that's quite necessary, so I'm going to remove that. But I am going to create this policy on top of the bucket, which allows only SSL requests. So we will definitely do this to make sure that this is secure and over secure transport. So deny anything that's not over secure transport. Okay, so if I were to just do this part, let's do sam build. I just run this in one command. So we're building this. Again, this is what I love to do. I add a resource or two and then deploy it so that it gets created and then it's out there. Okay, so now we have that. So I'll do sam deploy and deploy it out there. Deploy this change set. Yes. Pardon me. So again, this is going to create an empty S3 bucket that now we can use to store all our files and everything else. So now I've created this. I've created the shell, the step function, and I've created a couple lambdas to do Amazon Transcribe. Okay. Now if I come over into my account and go back to my CloudFormation, I can click on resources and see exactly all the resources that were created, including my S3 bucket, which is here, which is cool. Okay, so I'm going to, behind the scenes, copy my file over into this. And sorry, bear with me as I do something off screen. Hate doing off screen, but I'm just trying to get something done. So what? Let me explain. I already have a file from a YouTube video. So I'm taking one of the office hours videos that I've already downloaded the video and I've already run through. I've already run it through processing and media convert. So now I have a file that I know we can run through Transcribe because I've done it in the past. So that's what I'm working on off screen, is copying that file into our new bucket that just got created. Yes, I'm using the CLI to do that. And let's hope this works. Okay, it's copying the file. I have to copy it from one region to another, and it's in a different account. So that's why I'm doing it off screen, just so that we're okay. It's getting there. Okay, so now here it is. All right, cool. Okay, so I'm totally cheating. Instead of doing this part here, I'm just putting a process file into our S3 bucket, just so I have one, just so we can start actually testing this thing out. So now what I can do, I can go back to my my step function. I can say new execution, and now I have a bucket that we just created, and I have a key, which is the location of the file. And so now we can actually just maybe actually try this. So bucket name goes to here. The key name is this. Now, does the key name start with a slash? That's a good question. We'll find out, I guess. I think it doesn't. And this is the audio format of that. Again, I'm cheating. I downloaded this file from YouTube manually, and then I put it through Media Convert so it got into the proper format. But I should be able to click Start Execution on this and get going. Let's see what happens. Hopefully Transcribe starts quickly, and it failed. Cool. All right. What's the failure? Actually, I already have my CloudWatch logs open for this Lambda. An error occurred. Provided cannot be accessed. Make sure you have read permission and try again. Interesting. Okay. So now yesterday I was worried about this exact scenario happening. So here it is. So Transcribe start kicks off here. We've given this Lambda function the ability to start the transcription job. But what I don't know is how do we grant access to that location? That's what I'm a little unclear on just by using the APIs. And so we're just going to have to do some troubleshooting. Again, you get to watch me try and figure out what the heck I'm doing and reading the documentation and everything else. Okay, so let's pull up the documentation for this. Okay, if you set output, that's not what I want. What am I actually setting? This is the media file URI. Oh no, got lost. Start transcription job. Media file URI. There it is. See, a lot of times, so I'm trying to determine here, a lot of times when you call something like this, you give the service here, Transcribe, a role to use that can go and access all your data. Here in the sample that I was looking at, that doesn't exist. And this API doesn't seem to have it. So let's go back to where I'm taking all this source code from and see how they are giving permissions to I don't like the way they. So here, what they've done is they've given every single Lambda. Again, this is the blog post that I originally am pulling everything from. Here, they're giving every single Lambda function the same Lambda service role, which I don't like doing. But one of the things we could try doing really quick is just giving the Transcribe start access to our bucket and see if that fixes it. So here for the policies, for the role, for this Lambda function, computer, stop. That's really weird. I didn't say that. Yeah, see, and again, they're being, that's way too much access, but I can fix that later. So here, what this is saying is give all S3 access. I really need to fix tabs before tomorrow, or next time I stream. I'm definitely gonna fix these tabs. Okay, so here, this is saying give all access to these buckets. So instead of that, I'm gonna say same errands as up above. All right. Look, I'm learning, getting better. I'm just going to do that in one CLI command. So I feel like this isn't the right way to do this, but we'll see. Because it feels like to me that the transcribe service is the one that needs to go and get from that S3 location, not the Lambda role that this is being called under. But I don't like to sit down and read documentation. I like to just try something. First as object names. I don't care about the object names. Deploy that. Okay, so transcribe documentation does have policy recommendations. Not recommendations, but examples. Okay, it updated. That seemed to have done it. So the input was what we passed in. The output, look, we got a transcription job. Now, that's interesting. That's really interesting. Okay, so it just was the Lambda role that needed access. So I open up Amazon Transcribe, and look, there's the job that we just kicked off. So cool. Cool. And then this is going to loop and wait. And you can actually see here all the different state transition and event histories. So execution started, task state entered, Lambda schedule, Lambda started, and so on. And so now what's happening is it's in this loop wait where it'll come in here, wait for, what did we say, 30 seconds, 20 seconds, then call transcribe status. The input is... So the input here is exactly the output from our previous one. Oh, we got, what happened here? We got an exception. Key error. You know what? Okay, the input here. Okay. Here, okay, so now there's a couple different ways to solve this. So what happened was the first time transcribe status ran, it ran with the input, there was a direct output of transcribe start. So the output here was put directly into transcribe status. It successful, looped around, came back. Next time it came here, the default input was the output of the previous Lambda function, which was status of in progress. So there's a couple different ways you can do this. You can express the inputs and outputs in a step function syntax and do routing there, that hurts my brain when I ever have to do that. So what I prefer to do is just kind of in each of my lambdas just pass through a lot of the inputs. So here the input to this lambda function included the input to the state machine, but the output was just this. So what I like to do is pass on the input with my output. So what I mean by that is if I come to transcribe start, oops, I didn't mean to have it open here. This is my transcribe start. The input was that JSON that we saw. The output was just these two variables. So I actually prefer to design it more so that everything kind of keeps passing through. So what I mean by that is I'm going to pass the input as an output as well, so that my next function would be able to get access to the media S3 location. If that makes sense, I hope it does. So here I'm just going to say complete pass through. And then this was, I think, key, right? Yeah, key. And then there was another, the content type. And I should pull in the event content type. Okay, so now my output to this is going to include the input. And now, because I'm going to keep chaining these together, I can either create a specific status for a transcribe status. I don't think it matters that much, but there's my transcribe job. So now this is the return of my first one. Now my second, let me pull up the status one here. Here the return value is just status. That's going to be a problem the next time it loops around. So here, what I'm going to do is copy over everything else. So now I'm going to call this, hold on, let me do it this way. Okay, so again here, now the input is going to pass along directly the output. So instead of is success, we're going to say, actually success, we don't really need to pass that on. We can drop that, but transcription job name is definitely what we need to pass through. So now the output of this is going to include transcription job from the input. I hope this makes sense. So now the return, this allows me to make sure that the inputs to all the different Lambda functions include all of the inputs from before. This is, again, there's like slicker ways of doing this, like where you can express inside the actual template like this, like exactly what inputs to put into the Lambda function. I find that just more challenging. I like to just kind of pass along this. So the output of this function is going to include all the inputs. So when this runs a second time, it'll inherit its own output, which should include transcription job. And that might make more sense when we run it, and I can kind of show you the deployment. But this did successfully kick off a transcription job. I actually want to cancel that job. We don't need to, can I? I apparently cannot stop a transcription job once it's in process. That's okay. It's going to waste resources. That's fine. All right. By the way, this also allows me to, by passing through all these different return values from the inputs, it does make it a little bit easier to reorder lambdas. Not always, but I think it does help. And my brain just works this way a little bit more cleaner. Okay, so hopefully, wrong window. what am I looking for? I closed it. I closed Safari. That wasn't good. That was not at all what I intended to do. Okay. Session's still fine. Okay. So now I've updated this. Let me rerun this again. I think it should make a lot more sense. So this is the input. Actually, let me rephrase this. So my first Lambda function, the input was that. The output lost all of that information and returned this. So when this Lambda function ran, the input was, the first time, it was this, which had what it needed. The second time, the input was just this, which was the result of the last time it ran. So again, like we lost all that data. But now I changed my return values to pass through the inputs. So hopefully this makes a lot more sense. And hopefully this doesn't fail because there's already a transcribe job on the exact same file running. We'll find that out. And I hope this works because I think I have to end the stream here pretty soon. Okay, so now look, the input was this, the output was this plus the transcribe job name. So we're in the wait phase. How long is this wait? I can't remember what I defined it as. 30 seconds. Let's stall for 30 seconds. So the input to transcribe status is going to be this entire thing. And transcribe status is going to drop the success because that isn't that interesting. And is going to add, what did I call it? A new status. So here, now the output of transcribe status includes this. And this status in progress is what this if block is looking for. So that right here, that if block is transcribe finished. It's looking at that $.status. It's looking at the output status variable and saying it's in progress. It doesn't match failed or completed, so it goes back to the default, which is transcribe wait, which waits another 30 seconds. And really, this is going to take a while, is my guess. In fact, the previous one is still running. So it's going to take a while. I'm going to cut the stream off here once I verify that the second time transcribe status hits, it's going to be fine. And maybe it's already even done that. Cool. Okay. So what do we accomplish today? We accomplished a lot. So we added an S3 bucket. We have a sample file that I manually uploaded in there, and we have a step function that is going through and starting to orchestrate this whole entire process. Let me git add.a, git commit, added S3 bucket, started state machine. And again, I'm putting all my code into this repository here. You should be able to find it. It's a public repository. If you go to Ryan J. Lowe is that's my name like everywhere. But you should be able to find it here and be able to follow along with everything I'm doing as I'm streaming this. Cool. I think that's where I'm going to end it for today. Thanks. This has been fun. Again, like my job is to inspire and educate developers to build with Alexa. As such, I need to build with Alexa, so I'm keeping my skills up to date. I need to build real life things. So this is my job. This is what I need to be doing, and I might as well be live streaming it. Maybe other people will find it interesting. Who knows? I don't know. If nothing else, I'm having fun. And yeah, so thanks. And I'm not sure when I'm going to be able to stream next. I need to figure out a regular time where I can stream. So I have a nice schedule. But until then, thanks. Bye.